But, oh, yep. Sorry, should have given that to you before. So again, yesterday we started looking at solving log equations. Again, we talked about two different ways to solve log equations. If you have just one logarithm in the equation, you normally want to switch forms using kind of the way we switched from log to exponent form in lesson 1. If there are logs on both sides, we could cancel out the logs and just set the insides equal to each other. There might be times where they combine logarithms together. So when they do that, we have to use properties of logarithms. Because logarithms and exponents are pretty much the same, we can derive the properties of logarithms from the properties of exponents. For example, the product property of logarithms is basically the same as the product of power property from exponents. So you can kind of see the similarities. Again, if you remember in our last unit, if we had two bases that had different exponents, we could combine them into one base and add the exponents together, doing x plus y. Kind of the same thing with logarithms. So if you see two logarithms, kind of the opposite, with the same base, and they're adding together, like log x plus log y, I can combine them together into one log with the same base. This base does have to match, so notice how all of these b's are the same. But I can combine the logs into one, and make this x times y inside of the logarithm when I combine them. If you remember our division property with exponents, we kind of want to do top minus bottom when we're dividing exponents. And so since we're subtracting here, if we have two logs that are subtracting now, and if we're doing x minus log of y, I can combine them into one log again with the same base and do x divided by y inside of the log. I'm kind of dividing the logs if I'm subtracting, so they're kind of opposites. So again, adding logs, I multiply. Subtracting logs, I divide. And then the last thing, again, if you remember, if we had a base with a power and another power, I can multiply those powers together, x times y. Now, since our power is basically the same thing for a logarithm, you can pretty much take this and move it to the front, and it becomes like an x, kind of in front of my whole thing. That's if you see an exponent, or vice versa, if you see a number in the front, sometimes they'll have you move this back up to be an x. So it kind of just depends on how they want you to kind of move it. You can kind of move it both ways with logarithms, exponents, since we're really just solving for exponents in the first place. So we're going to look at, I think there's 8 examples down here, kind of 4 of each. So looking at this first one, they give us two different logs. Log 2 of x plus log 2 of 4 is equal to 3. If I'm adding these two logs together, I can combine them into one logarithm and take the insides and multiply them together. What do I get if I do 4 times x? I get 4x. Now this becomes like yesterday, so 2 is my base, 3 is my exponent, and I set it equal to the inside my argument. 2 to the power of 3 gets me 8. If I want to find x, I can divide by 4. I get x would equal 2. Again, double check if you plug it back in your log, you don't get a negative. I don't. So you get, bless you. Bless you. For 2, again, if you see kind of this number in front of a logarithm, you can move it back and be an exponent. So I could write this as log base 3 of x squared is equal to 4. I only have a log on one side, so I'm going to switch forms. 3 becomes my base, 4 becomes my exponent. I set this equal to the inside now, x squared. Do the exponent, 3 times 3 times 3 times 3, 81. And then take the square root of both sides, I get x is going to be equal to 9. Now again, normally I do plus or minus here, but I don't want to do minus 9y. It would make it extraneous, right? So normally when I do solve equations with square roots, I want to do plus or minus. But here, if I put negative 9, right, negative 9 would make this extraneous. So make it negative. So I really don't want to put the negative 9, so I'm not going to put it. That's why I don't put plus or minus 9 there. That kind of makes sense. Normally I would when I take the square root of stuff. So those are those two. This one, kind of the same, and kind of combining those two together. So again, we're adding two logarithms. So make this 1 log base of 3. I'm multiplying. So I'm doing 3 times x squared gets me 3x squared. 3 times 3 gets me 9. You have to multiply the 3 to both things in the other one. So kind of like distribution. I only have a log on one side, so I'm going to switch forms. 3 to the power of 3 and equal 3x squared plus 9. 3 times 3 times 3 gets me 27. Minus 9 from both sides, I get 18 is equal to 3x squared. Divide by 3, I get 6. And then take the square root of both sides, and now I just leave this as the square root of 6. And same thing, I don't want to put plus or minus because the minus will possibly make it extraneous. Mm-hmm. And then number 4, again, we're adding these two logs together. So again, I want to multiply the insides. I'm doing x times x gets me x squared. X times negative 9 gets me negative 9x. I want to switch to exponent form. So 6 is my base, 2 is my exponent. This is equal to x squared minus 9. 6 times 6 gets me 36. This is a quadratic. I want to get it equal to 0, so I'm going to minus 36 to both sides. And think of numbers that multiply to negative 36 that add to negative, oops, I wrote 9. Negative 36 that add to 9. What numbers can I use? 12 and, yeah. Negative 12 and 3. Because I want to add to negative 9. So I get x minus 12, x plus 3. And so I get x is equal to 12, x is equal to negative 3. And if you plug in the 12, we're okay. But if you plug in the negative 3, this will become a negative, this will become a negative 2. So this would be extraneous. Those 4 are examples of only having a log on one side, combining logs, or using our log properties, and then switching forms. Those, I think, are the little bit harder ones, just because you have to know how to switch forms. So for this section down here, you should notice there's kind of logs on both sides. Now, I want to try to combine the logs if there's more than one log on one side. So again, I can combine these on this side and multiply 54 times x gets me 54x. Now again, if you have logs on both sides, I can kind of cancel them out, set the insides equal. If I want to find x here, I would divide by 54. What can I take out? I could take out a 3, I think. I'm left with 2 over. Oh, can I take out a 6? And it's 1 over what? Now this one we haven't done a subtraction yet, but if we are subtracting logs, I can combine them and divide. So take 35 and divide by x. Again, these cancel. I get 35 over x is equal to 7. You could think about this a couple different ways. You can either like cross multiply if you want to do that, or you could multiply by x if you want to move the x to the other side, but you should get something like 7x is equal to 35. And then I want to divide by 7. Or you could just look at this and know what's 35 divided by what gets you 7. 5. I think you guys, some of you are smart enough to just know that. I would think, maybe. X would be 5. Again, if you double check and plug it in, it doesn't make a negative, so it's not extraneous. So last two. This one, there's two different rules we have to do. If you have a 2 in the front, again, I can move that back up and be an exponent, make it x squared. On this side, I have two different logs, so I can combine them together, multiply the insides. I'm doing 4 times 6, or 16 gets me 64. Again, if I have logs on both sides, cancel them out. So I get x squared is equal to 64. Take the square root of both sides, I get x is equal to 8. Oops. And then last one for 8. Again, I'm multiplying these two logs together, so I get x plus 2. I'm going to just write them like this for now, x minus 1. Now again, I can kind of cancel these out. You should multiply these, so again, you have to either do FOIL or double distribution or the box if you like the box. X times x gets me x squared. I get minus 1x. Then I want to multiply the 2. I get plus 2x minus 2 is equal to 10. Combine my like terms on this side, I get a plus 1x. I can minus this 10, so I get minus 12. Equals 0. I want to factor. I want to think of numbers that multiply to negative 12 that add to positive 1. Should be 4 and negative 3. I'm going to get x plus 4 and x minus 3. Means I would get negative 4 and positive 3. And if I plug negative 4 in, negative 4 plus 2 gets me a negative. Negative 4 minus 1 gets me a negative, so this is an extraneous answer. But if I plug in the 3, that's good. 3 plus 2 is 5. 3 minus 1 is 2. So 5 times 2 gets me 10. So matches this side. So that's solving if there's logs on both sides. You kind of combine all the logs on one side if there are more than one. If there's logs on both sides, you can kind of cancel them out, set the insides equal, and then you kind of have to do all the rest. Solving algebra, fun stuff. So if you look on the back of your homework from yesterday, yeah, that's true. So the bottom ones, there's 4 on the bottom, and then there's a couple on the back. So no, I think the ones on your progress check, there are ones I think like 22 and 20. So I don't think there are ones like 23 and 24. Those are kind of big. To be fair, I don't think 23 and 24 are that. They look bad, but they're not that bad. 24 is really not as bad as it looks, I think. So that's your homework for tonight. You have the rest of class to kind of work on. You guys still have like a half an hour. So